السلام عليكم ورحمة الله. بالمحاضرة السابقة ناقشنا أو we said about the laws of thermodynamic، وحكينا إنه في عندنا 4 قوانين للديناميكا الحرارية اللي هي الزيرو لو اللي بيعمل define temperature and first law define the energy and second law define the entropy as well as third law provide a numerical value to entropy. Okay. وحكينا إنه zero law of thermodynamic deals with thermal equilibrium and provide a means of measuring temperature. The first law of thermodynamic deals with the conservation of energy and introduce the concept of internal energy. And the second law of thermodynamic is also introduced the concept of entropy. The third law of thermodynamic defines the absolute zero of entropy. The zero law of thermodynamic: when two bodies equally of temperature with a third body, then they have equality of temperature. So if we have A and C, then we have B and C also the same temperature. So if A and C are in thermal equilibrium, in other words, at the same temperature, and B and C are thermal equilibrium, then it follows that A and B are at thermal equilibrium. In other words, at the same temperature. Even zero law of thermodynamic defines the temperature. Heat. The term heat Q is probably used to describe the thermal energy transferred into or out of the system from a thermal reservoir. Reservoir means الخزان الحراري. Okay. Sign of Q. If Q greater than 0, then the system gains thermal energy. أما إذا كانت Q less than 0 فهذا يعني إنه السيستم lose thermal energy. Okay. Heat. So heat is the transfer of energy. إذا الهيت هي عبارة عن نقل للإنرجي. Heat is a form of energy. إذا الحرارة هي شكل من أشكال الطاقة. It's a scalar quantity and it's measured in joules. إذا يتم قياسها بالجول. When we heat a substance، إذا عملنا heating لأي مادة، it becomes hotter or changes state. So the old metric temperature scale is Celsius. إذا الوحدة temperature is Celsius and was defined so that 0 Celsius is a freezing point of water. إذا درجة تجمد الماء هي عند 0 Celsius and 100 Celsius is the boiling point of water. So the transformation between temperature scales is as follows. إذا بدنا نحول من كلفن من سلسيوس لكلفن، إذا التمبريتشر لكلفن equal T لسلسيوس زائد 273.15. أما إذا بدنا نحول فهرنهايت لسلسيوس فتي لسلسيوس تساوي 5/9 في التمبريتشر as a function of Fahrenheit ناقص 32. So heat always flow from an object with excess energy to an object with an absence of energy. Heat flows from hot to cold, and 1 calorie equal 4.186 joule. This is convert calorie to joule. إذا بدنا نحول من calorie لجول، إذا 1 calorie equal 4.186 joule. And also 1 kilocalorie equal 4.186 kilojoule. Okay, the absolute Kelvin temperature scale is based on fixing temperature of the triple point for water. A specific temperature equal T equal 273.16 Kelvin and pressure is 611.73 Pascal, where water can coexist in the solid, liquid, and gas phase in equilibrium. Then this is the triple point for water اللي هي ممكن ايش يتحول عندنا ice اللي هي solid and water, liquid, and gas. Then this is the triple point. And here the figure shows the pressure versus temperature. So the absolute zero, when we have this T temperature in Kelvin and we have the pressure, so the temperature equal 273.16 Kelvin في البري على BTP for an ideal gas constant. Then we can see this P here, the pressure, and this is the triple of pressure, okay, and here the temperature of Kelvin. So the pressure over P for divided by triple pressure for an ideal gas constant volume thermoscope. Then VTP, the pressure of the gas in constant volume gas thermoscope at T equal 273.16 Kelvin. Okay, heat capacity. The heat capacity is the energy required to rise the temperature of an object by 1 Celsius. Okay, the heat capacity depends on the mass of the object and the ability of the object to resist the flow of heat into or out of the object. So Q equal mvCx delta T. The constant Cx is called specific heat of substance X. And the SI unit of joule per kilogram Kelvin. Specific heat is the heat capacity per unit mass. So the C equal limit لا Q over delta T as delta T goes to 0 وهي عبارة عن المشتقة اللي هي dQ by dt heat capacity. And C equal 1 over M وتساوي dQ by dt, and this is specific heat capacity. إذا الهيت capacity capital C equal dQ by dt and small c equal specific heat capacity dQ by dt. M is the mass in kilogram, C is heat capacity, joule for Celsius, and small c is the specific heat. Okay, هون بدنا ننتبه for heat capacity and specific heat C capital or C small. Because the differential dq is inexact, we have specified under what condition heat is added, or more precisely, which parameters are held constant. This leads to two important cases: the heat capacity at constant volume, Cp, and the heat capacity at constant pressure, Cp. So Cv equal dq by dt at constant volume, and Cp equal dq by dt at constant pressure. For isothermic, C equal infinity, and in adiabatic process, C equals 0. So this process, isothermic and adiabatic process, we will discuss later. For monoatomic, CV equal 3 على R over 2, and CP equal 5R over 2. This is monoatomic, يعني one atomic. 1 atoms. Diatomic 2 atoms, CV equal 5R على 2 and CP equal 7R على 2. A common use of heat equation is to determine the final temperature of mixture of two different objects at different initial temperature. Then we have to mix two different objects, two different substances at different initial temperature. يعني Q hot equal minus Q cold. This is necessary to compensate for different direction of heat flow. This means that C1 M1 delta T1 equal minus C2 M2 delta T2. So the final result for the T final after mix different object at different initial temperature, T final equals C1 M1 T1 زائد C2 M2 T2 over C1 M1 زائد C2 M2. Or this would be the final temperature of mixture of two materials with different mass, specific heat, and initial temperature. This expression is not valid if there is a phase change at any time during the process. إذا تغيرت الماتيريال من حالة إلى حالة, this relation it's not valid. This is the table for specific heat value for selected substance for aluminium, copper, gold, iron, and so on. Okay, heat and latent heat. Latent heat, الحرارة الكامنة, is defined as the heat absorbed or released when a substance changes its physical state completely at constant temperature. So, latent heat diffusion or latent heat of vaporization. Latent heat fusion is the heat absorbed when a solid melts at constant temperature. بينما latent heat of vaporization is the heat absorbed when liquid change into vapor at constant temperature. So this is the difference between the latent heat fusion and latent heat of vaporization. So we have a liquid and latent heat, then we have vapor. And we have this solid. During the latent heat, we have liquid. So from ice to water. Here is the example. Okay, then latent heat, the amount heat required for phase transition is given by Q equal ML, where Q is the heat, L latent heat, and M is mass. Example for C for ice approximately equal 2092 جول لكل كيلوغرام سلسيوس. أما إذا كان عندي اللتت we have ice and زائد water فتقريبا بتساوي 3.13 جول لكل كيلو جرام. أما for water C for water تساوي 4184 جول per kilogram Celsius. So for water and steam equal 2.26 في 10⁻⁶ جول لكل كيلو جرام and for steam equal 2010 جول. C steam equal 2010 جول per kilogram Celsius. Example, 10 kilogram of ice at 0 Celsius is dropped into steam chamber at 100 Celsius. How much steam is converted to water at 100 Celsius? Either Q cold equal minus Q heat, and we have M ice times L latent F زائد C لل H2O مضروب في MH2O في دلتا تي للووتر تساوي ماينس M ستيم في L V. إذا M ستيم equal ناقص 0.33 كيلو جرام. The negative sign on the mass is acceptable here since it represents the mass of steam that was lost. Okay, either negative because it's lost, converted to water, إذا تحولت إلى ماء. Heat and latent heat transformation L is the energy required for 1 kilogram of substance to undergo a phase change. Q equal plus minus ml. Specific heat C, small c, of substance is the energy required to rise the temperature of 1 kilogram by 1 Kelvin, unit joule per Kelvin kilogram. So Q equal M في C في delta T. Molar specific heat C of gas at constant volume is the energy required to rise the temperature of 1 mole by 1 Kelvin. So Q equal N في CV في delta T. In phase transition involved, then the heat transfer is Q equal plus minus M في L زائد M في C في delta T. The molar specific heat gases depends on the process path. So we have Cp, the molar specific heat at constant volume, Cp, molar specific heat at constant pressure, Cp equal Cv زائد R, and R is the universal gas constant. Gamma is the ratio between Cp and Cv. So we will discuss how to derive this equation in next lecture. And this is the end of this lecture, and thank you for your attention.